So I'm going to present here the work of a PhD student who is Omar Mirad. He's working on the treatment of water in order to use a platform which is actually only in simulation. This is, let's say, a prospective approach. And he tries to integrate models of crops and hopefully of soils together with the use of this platform to adapt the quality of the water to plant demands. So we are in the, let's say, idea of decentralized system. So on the left you have, let's say, the mainstream of water reuse, but we really want to go to decentralized approach where we can be much more flexible than using the output water of classical treatment plants. And this is precisely around the notion of flexibility of decentralized system that allow us to keep some nutrients when it is needed and to remove it during periods where the irrigation is not needed. So this is precisely what we try to do, and of course in the presence of what we call here input disturbances, which include actually the weather forecast, the weather data. Okay, so this is the platform we are working on. It has been developed within another PhD within the framework of a European project that was called Control for Use. And the idea was to come up with the most flexible platform we can imagine in terms of managing the nutrients in the water. Nutrients means here we just focus on nitrogen, not on phosphorus and potassium, but it could come later on. You have the data of the process here. Okay, this platform includes a number of valves and some control of flow rates in order for us to distribute the different flux of wastewater within the system. Okay. Pop. Yes. Playing with these valves, in fact, we can completely change the way the different tanks are connected, and we can or not have some places for anoxic treatment or not, and aerobic treatments. Playing with these different valves, we can notably use what we call here the configuration C2, which was, let's say, the best in terms of time response in order to switch from different treatments where we keep the nitrogen or not. So now we concentrate on this approach. In order to couple the use of this platform with the plant crops models, we used the model of crops in order to know exactly over a given horizon period of time what was the best trajectory in terms of nitrogen concentration to be given to the plant and water, not only water quantities, but water and nitrogen over the time in order to maximize the biomass produced, or alternatively, for example, to guarantee a minimum revenue for the farmer. So here you can integrate a number of constraints. If we go towards the quality of soils, or as was just underlined by in the plenary session, we could add here a number of constraints in order to get the best trajectory to be given to the plants. And then we can, you showed just some simulation Here, when we do not need water, then we are able, water for irrigation, then we can just remove nitrogen and maintain the concentrations under a given level. But if the set point that you see, this is the, how do we say, très pointillé, dots lines, yes, you have the optimal concentration of nitrogen, then we are able to follow these nitrogen changing, using the flexibility precisely of the platform. Now, the question is, okay, this works quite well. We can do it with the appropriate time response to go from periods where we do not need irrigation and periods when we needed irrigation. But the problem is what happens to micropollutants. So, with respect to the thesis of Farouk Aishouche, who developed the platform and showed these results, now with OMA we are looking at the micropollutants dynamics into this platform and see what happens to the dynamics of these micropollutants. So we have added in the models the dynamic of the of two micropollutants that have different properties. I leave that for here, but what should be shown is the following results. So on the left side, you have what happens when we do not need water for irrigation. It means that we maintain everything using the flexibility of the platform under the regulatory standards. And on the right, you see what happens to the same molecules if we now follow the optimal trajectory for the nitrogen. What should be kept in mind here is that it does not change so much the removal rate when we keep some nitrogen or not. So that was the main results of what we wanted to show. Either in a, let's say, closed loop solution or open loop, we obtain the same kind of results in terms of micropollutants. The most important thing to keep in mind is that in terms of regulatory impacts, in terms of micropollutants, this flexible solution does not impact the treatment of micropollutants. We have, let's say, the same results with or without the irrigation mode using these flexible platform. For the next steps, we will go towards the integration of the soil properties, and we will couple. Excuse me, this is very small. Yeah, we will couple the soil plant interface in order to go further, a step further into the evaluation of these strategy. So, thank you for your attention.